function of the design, whether it working properly or not. But the disadvantages of the direct testbed is actually the designer have to be observed manually. But the random testbed, the designer do not observe randomly, and they can random the data and also random the control signal. You can see that the random testbed, you can see that it covers the device, the test, and the output of random testbed will be the stimulus data for stimulus input for the device test, and the output of device test will be the input for the random testbed. For example, the 5-volt data input will be go to the, and the right enable signal, read enable signal will be go to the device test, and the output of device test, the 5-volt data out, 5-volt full condition, 5-volt empty condition will be go to the testbed. The dry lock and green lock will be sent to both the testbed and the device test. This is more detail about random testbed, the schematic of random testbed. The generator will be generate the data input and the write enable signal. This also generate the read enable signal, because our design the write action and read action operating on two different clock domains. So I separate for you guys to easy to understand about it. For example, the generator I separate into the push generation and pop generation. The push generation will generate the random data for the write action, and the pop generation will generate the random read enable signal for the device test. Both of them go to the device test. The outside black rectangle, that is the top module, including the testbed and the device test. You can see it. The border between the testbed and the designer test are connect together throughout the interface module. And also we have the function cover. The function cover to measure the whole testbed and the design to design how many random data, how many inputs have to be sent to the testbed. For example, 100 or 1,000 or 1 million. What number is the best for enough for our design? On the testbed module, we have some subclass and some tag and function. For example, the genpop to generate the data input, genput to generate the read enable signal to take the data. On the interface, it will be separated into the 3 different interfaces. First one, I would like to talk about the interface module. The interface module will be separated try interface, read interface, and monitor interface. Why have to divide into 3 modules? Because I would like to become write and read file working on 2 different clock domains, so I have to separate into two different interfaces. First of all, the write interface, I have the write interface right here, and then the write interface working on the right clock domain. So I clock in on the port working on the right clock domain into one clocking, and then map up, and then I look on the port into the map up calling the right testbed. The same idea I have the I separate the read interface like this one. The read interface I look on of the map up working on the read clock domain into read interface, and then I clocking on the port together, and then I group on the port together on the map read testbed. Why I have to clock it on the port together? Because this one working on one synchronized on one clock, so it make our design avoid gray condition. And also the monitor port like here, the monitor port to monitor the input signal and output signal. So I have one different independent interface for the monitor module. This is the testbed module. In the testbed module, the first one you see that I connect our test band with the interface, the write interface, read interface, and monitor interface. And the first one I instantiate on the class, separate class into this module. As you can see that I include the scoreboard class, the write file class, read file class on it, and I set up the handle and allocate a new block of memory for them. You can see I call a new write file, new read file. The handle right here to connect to the design. And you can see that the cover up, this is the cover function, the cover up, the cover data, and it will be cover the data. And I create a new handle for it, allocate a new block of the memory for the function cover. And this is the main part of the random test band. The first one we can see that the first one has to be the reset. Reset which will be send the reset signal to reset the device the test to make it on the first condition that the reset, and after the few clock cycle I turn off the reset signal. First one I turn on the monitor pop action and the monitor push action. I turn on to wait for the input to make it ready for the input data incoming and then the output data coming out. You see that the monitor push it will be monitor the data and then it will be sent to the various color data and then sent to the scoreboard. The scoreboard functions add item. When the data input coming in, it will be monitor the input and then the data will be sent to the scoreboard for the tag the add item.